Greetings, fellow nerds. Thought I would talk to you about oxidation reduction reactions. Oxidation, I'll do it in red. Oxidation, we are most often going to abbreviate it as OX, and what it represents is a substance that has lost electrons. I really should say electrons. There we go. Reduction, though, is, I'm sure that you can kind of flip it around here. So if we call oxidation loss of electrons, then reduction is the gaining of electrons. Okay? So redox reactions, obviously we shorten the name oxidation reduction to redox. Redox reactions are a very, very, very fundamental and important type of chemical reaction. This is a redox reaction. Let me show you why. I'm going to, we could write out the net ionic for this, and I think that the net ionic is probably the best way to go to see this. So let's go take a look at the net ionic real quick. We have zinc. Again, if you don't mind, I'm going to drop states just because for time's sake, no other particular reason. Okay. So here's the big thing. I want y'all to focus in on, let's start by looking at the zinc for just a minute. Notice that the zinc here, and I'll tell you what, I'll go with green here. Notice that the zinc went from neutral to a +2. So I just kind of want to focus on the zinc for just a minute. In fact, one thing that we could do if we really, really wanted to is bring the zinc out of context for just a minute. And so we could say, let's just look at our zinc here. And so this would be zinc going to zinc 2+. Hopefully you can see what's happening here. The zinc, what does it mean that zinc went from neutral to 2+? Well, atoms can only gain or lose electrons. And so if it's positively charged, then we've learned it has lost electrons. And so it has lost electrons over the course of this reaction. In fact, you can see, hopefully, it has lost 2 electrons over the course of this reaction. Because zinc is losing electrons, then this is what we call oxidation. Zinc, we would say then, is getting oxidized. Now, we could go take a look at the copper. Again, we're going to do the same thing. I'm going to kind of isolate it in this way. So looking at the copper here, pulling it out of context, just like we did before. Whoop. And it would go something like this. So we would have copper 2+ forming copper. All right, notice that it went from an ion, a cation, 2+, to now neutral. What happened to the copper's charge? Well, hopefully you can tell that copper had to gain electrons. So in order for copper to go from copper 2+ to just neutral copper, it has to gain negative charge or gain 2 electrons. Hopefully you can now see that copper is gaining electrons, which means then, or we would say that copper is being reduced. So students, this is an oxidation reduction, aka a redox reaction, where the zinc is being oxidized and the copper is being reduced. I want y'all to notice that zinc is losing electrons. It's losing, in fact, it's losing 2 electrons. So it's these 2 electrons that the copper is gaining. That's a huge point that I want you to see. So the copper here, I'm going to get rid of some of these marks. So again, the 2 electrons that the zinc is losing are the same 2 electrons the copper is gaining. Matter cannot be created and matter cannot be destroyed, which means, students, where there's an oxidation, there must be a reduction and vice versa. If there is a substance gaining electrons, getting reduced, then it must be obtaining those electrons from somewhere else. Again, likewise, if a substance is losing electrons, those electrons have to go somewhere. Well, who are they going to? They're going to the substance that's being reduced. So the two must always be together. Last but not least, I want to mention these are what we call half reactions. So this right here, students, is the oxidation half reaction. And this, of course, is the reduction half reaction. A half reaction is where we are only focusing on either the oxidation or we are focusing on the reduction, but we're not focusing on either one. Why do we call them half reactions? Well, because there's 2 processes at play, oxidation, reduction, and so obviously looking at one out of the 2, aka half reaction. And we can always look at any given reaction in terms of its oxidation and its reduction components.